Okay, so a few tips for section 9.3. The first thing, the first kind of big concept in section 9.3 is just understanding how to work with an exponent that is a fraction. And the main thing that you have to remember about that when you're dealing with an exponent that is a fraction, when you look at the exponent, whatever is on the top of that fraction, the numerator, that is going to be used as an exponent, meaning you're going to raise to that power. But whatever is on the bottom in the denominator, that is actually going to be used as a root. So you're going to take whatever root's on the bottom, and then you're going to use whatever's on the top as an exponent. So for example, if you have exponents that are 1 over a number, that's the same thing as just taking the root corresponding to whatever number is on the bottom, right? Because again, it's whatever number's on the bottom is the root. Like in this case, 36 to 1/2 power. 2 is the root. That means you're taking the square root. And then 1 would be the power in this case, which is not going to change anything. All right, and again, remember, you've got all of my completed notes under the Course Materials tab. So you've got all of these examples in there that you can go through and reference. Now, with the exponents that are rationals or fractions, again, the main thing is if there's something other than 1 in the numerator of that fraction, then that is going to be used as an exponent. So for these examples, notice it was a two-step process, right? What I did first was I looked at the bottom number and I took that root, right? The bottom number is 2, that's a square root. Then I looked at the top number, in this case a 3, and I raised to a power, right? It's a two-step process. So for example, down here, -8 to a power of 4/3. First thing I did was look at the number on the bottom and take the root. Then I looked at the number on the top and raised to that exponent. And you always want to simplify. You always want to simplify as much as you can. Okay, so that's the first big concept. The second big concept in section 9.3 is understanding that when an exponent, anytime, whether it's a fraction or not, anytime an exponent is negative, what that means is you need to flip or move that term. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. All right, and that's what this is saying. So, anytime you're given something with a negative exponent, like 27 to the -2/3 power, the first thing you want to do is make that exponent positive. And the way you do that is by flipping. All right, this was in the numerator, so I moved it. I did 1 over 27 to a +2/3 power. And once the exponent is positive, then you go back to the same thing with rational exponents, where the number on the bottom is a root. That's a cube root. And the number on top is the exponent. All right, and again, this is true whether you're going, taking it from the numerator to the denominator or from the denominator to the numerator. You're basically just taking the reciprocal. So like this example down here, the exponent was -1/3. And so notice what I did there to make the exponent positive. I just took the whole thing that was being raised to a power, -64 over 125, and I flipped it. Okay, so the way you make an exponent positive is by taking the reciprocal of that term. All right, if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. And if it is a fraction itself, then just flip it. All right, now you're going to be pulling those things together, using all of that information to simplify. So you should never have any negative exponents, and you should simplify any rational exponents that you can. Now, the last thing you're going to be doing in this section is using the rules of exponents to simplify. And so these are all rules that you've seen before. You may need to review them a little bit. But these are all things that you've seen before. You're just going to be using them to simplify working with these exponents. So things like when you multiply, exponents are added. When you divide, exponents are subtracted. When you raise a power to a power, exponents are multiplied. All right, those are the types of things that you're going to be using here. All right, and again, you've got lots of examples in here in my posted notes that you can look at to see how you're going to use these to simplify. But again, notice it's just when I see that I'm multiplying with exponents, then what I did is I came right over here and I added my exponents together. All right, now if they're fractions, that might involve, getting a common denominator and things like that. But it's using those rules to simplify. And then lastly, using those same rules, you can combine radicals together. And this kind of pulls everything together from this section. So if you're trying to combine radicals and get to one radical, then what you're going to do there is change everything to a rational exponent. Again, the number on the bottom is the root, the number on the top is the exponent. And then use the rules of exponents to simplify from there. All right, so again, all of these examples you have, this is worked out completely for you under the Course Materials tab. All right, but let's look at a couple together. All right, again, start with the Learn. Make sure you're going through and looking at all the information there. And then when you go into practice, you're going to see these three main concepts. All right, so let's start with just making sure that we understand what to do when we have a rational exponent. So let me find one in here. All right, so like this one. I have 27 over 64, and I'm raising that to a power of 2/3. So when the exponent is a fraction, again, all I'm going to do is take what's on the bottom as a root and what's on the top as an exponent. So that means I'm going to take the cube root of 27 over 64, and once I do that, then I'm going to raise that to the second power. So we'll start with the cube root. You know you can break up quotients. The cube root of 27 over the cube root of 64. The cube root of 27 is 3. The cube root of 64 is 4. And then don't forget, that has to be raised to the second power because that was the numerator in this fraction. So when I finish this out, I'm going to take 3 and square it. That'll give me 9. Take 4 and square it. That'll give me 16. And then I have simplified. I have taken this and raised it to the power 2/3. So I'm going to come back over here. I'm going to input my simplified answer using the keypad here. There we go. 9 in my numerator, 16 in my denominator, and I have completely simplified that rational exponent. All right. Now again, if I'm working through these and I come to a negative exponent, like this one, the only difference is I'm going to use the reciprocal in order to make that exponent positive. So if I've got negative 27 over 64, and I'm asked to raise this to a power of negative 2/3, all right, again, when you see a negative exponent, that's the first thing you need to take care of. And the way you do that is you take whatever you're taking that exponent and raising it to that's negative, and you're going to flip it. Use the reciprocal. Right, so I'm going to flip that, becomes negative 64 over 27. And when I do that, when I take the reciprocal, the exponent becomes positive. And then I can work through it just like what I did up here. Right, I'm going to take the cube root, because that's on the bottom, of 64 over 27. and raise that to the second power. The cube root of 64 is 4. The cube root of 27 is 3. And if I square that, all right, notice I'm getting the reciprocal this time, which is 16 over 9. All right, and anytime you come across a negative exponent, so let me go back in again here, you always want to take care of that negative exponent first. I'm not seeing another one here. But just remember, if you do come across one where you, instead of having a fraction as your base, you know, if you look at something and you're asked to take, say, 16 and raise it to a power of negative 3/2, then all you do in this case to make that exponent positive is you take 1 over, you move it to the denominator. That makes the exponent positive. And then again, you take the bottom number as your root, the top number as your exponent. The square root of 16 is 4. And if I cube that, I've got 1 over 64. All right, so the majority of what you're going to be doing here is just that. All right, simplifying, understanding what to do with those rational exponents. The other things that you're going to see here, again, are going to be reviewing those properties of exponents. So like in a case like this, you're raising a power to a power. You want to understand that those exponents need to be multiplied together. All right, whereas in a case like this, you are multiplying, and you're going to have exponents. So those exponents in this case would be added together. All right, now let's go ahead and look at this one, because notice this is one of those cases where we're going to be writing this as one radical expression. So I've got the square root of x to the 5th times the square root of x squared. So when you've got more than one radical and you're trying to combine it, the first thing that you want to do here is write everything with a radical, or not a radical, write everything with a rational exponent. So remember how we do that. The exponent is on top, the root, right, this is a square root, is on the bottom. And the same thing over here, the exponent is on top, and the root is on the bottom. Then I say, okay, if I'm going to multiply with exponents, I'm going to add the exponents together. I'm keeping it 2 over 2 so that I have a common denominator. This is going to give me x to a power of 7/2, keep the common denominator. And then putting this back in radical notation, I'm going to be taking the square root, because that's the number on the bottom, of x to the 7th power. And just so you know, that is the same thing as if you were to write the square root of x and then put the exponent on the outside. It doesn't matter. Those are the same expressions here. And so you could input that information either way. All right, so I'm going to input my answer here. Again, this is the square root. Oop. All right, so the reason it's not allowing me to bring up that square root, what's happening here is every time I hit the square root, it comes up and it tells me the character you entered is not required. So if I go back and read the instructions here, then I notice it says change the following expression to an equivalent expression in exponential notation. So just watch for that. It'll either ask for exponential notation or it will ask for radical notation. I was trying to put mine in radical notation, but I should have entered this in exponential notation, which would have been here, x to a power of 7/2. So let me try this again. I'm going to raise that. I want my exponent to be a fraction. of 7/2. And then we're able to submit that information. So just watch for that. If it's asking you for exponential notation, then you want to leave it with an exponent. If it's asking you for radical notation, then you want to put it in its equivalent radical, square root, cube root, whatever it happens to be. All right. And so again, the only additional things that you're going to see here are situations where you might be asked to use more than one rule of simplification. So an example of a situation where you have kind of multiple steps that need to be considered would be this last example right here. And so, you know, you've got the tutor here. You can use that to walk you through each individual step. I won't take up a whole lot of time on the video to do that. But just to kind of let you know how I would approach it, when I have parentheses, I like to simplify what's in parentheses as much as I can first. And that's what I would do here. So I would go ahead and look at the x's, right? I would simplify those. We're dividing, so I can subtract the exponents as I need to. And the same thing with the y's. If anything divides out, do that. Make your life easier. And then when you have an exponent outside of parentheses, the main thing to remember there is that exponent has to be applied to every individual term. So you'll take 64 to a power of 1/3. You'll take whatever x's are left to a power of 1/3, and then you'll take any y's that are left to a power of 1/3, and then of course you will simplify from there. All right, so again, to see the specific steps there, go to your tutor and let it kind of walk you through. But that's how I would approach those problems where you're asked to kind of use multiple properties of exponents to simplify as much as you can.